Okay, this is Geometry 4.1 Triangles and Congruent Figures. Let's go ahead and start with review of the types of triangle. The first one here is acute. Here's an acute triangle. The acute triangle has all angles are less than 90 degrees. All right, an obtuse triangle has one really big angle. That angle will be right here, and that angle has to be greater than 90 degrees. And a right triangle has a right angle. So it's got an angle that is equal to 90 degrees. Okay, moving on, we got scalene, isosceles, and equilateral. A scalene triangle is a triangle with all different side lengths. So this side length is different than this one, and this one is different than the other two as well. That's a scalene. An isosceles triangle, that is a triangle with two side lengths that are equal, and an equilateral triangle has all equal sides. Okay? All right, now we've got some theorems here. First one here is if two sides of a triangle are congruent, then the opposite angles are congruent, okay? Opposite angles. So let's go ahead and write this out. Let's get an isosceles triangle out here. Let's go ahead and label these A, B, and C. And so if we know that segment AB is congruent to segment BC, well then we know oh, didn't do my magic thing there. Well, then we know, oop, I don't want to write that. Then we know that these angles are congruent, okay? So we know that angle A is congruent to angle C, all right? And the converse of the isosceles triangle theorem is saying the exact opposite. So if the two angles of the triangle are congruent, then the sides are congruent, okay? So this is saying the same thing, just in a different way, okay? So this converse theorem is saying that if we're given that angles A and angle C are congruent, well, then we know that these segments are congruent, okay? So pretty much saying the same thing there, okay? All right, so moving on. Let's see what we're going to be doing with this. All right, if we are given isosceles triangles, and we know that because we have these markings here showing that these signs are the same, we need to figure out the value of x here, okay? Now, if we know that these side lengths are congruent, then we know that these opposite angles are congruent. So if this angle here is equal to x, well, then this one also is equal to x. All right, and then from there, I know that all the angles on the interior of a triangle have to add up to equal 180. So I can say 48 plus x is equal to 180. Combine these like terms, we get 48 plus 2x is equal to 180. And subtract 48 on one side. Got to do it to the other side. And we're left with 180 minus 48 is 132. Divide by 2. And we're left with x is equal to 66. And there we go. All right, how about we try a different one here? What if we know that this side length is equal to 2x plus 3. And this one here is equal to 4x plus 7. Well, if we know that these side lengths are congruent by these markings, well, then we can just go ahead and set these two expressions equal to each other. All right, now we're going to go ahead and get the variables on one side and the whole numbers on the other. So I'm going to go ahead and eliminate the smaller of the two coefficients, coefficients being the number in front of the variable. So I'm going to get rid of the 2x. Do so by subtracting 2x's on both sides, and I'm left with 3 is equal to 2x plus 7. Now I want to get this x term by itself, so I'm going to go ahead and subtract 7 on both sides, and I'm left with negative 4 is equal to 2x. Divide by 2, divide by 2, I'm left with x is equal to negative 2. All right, now we got a little bit of a trickier one over here. How about if we're given this side length is equal to x squared plus 3x, and this one over here is equal to 40. Well, how do I solve this one? Again, these lines indicate that the side lengths are congruent, so we can set these expressions equal to each other. So I've got x squared plus 3x is equal to 40. And now, anytime I have an x squared or a quadratic, I need to go ahead and factor this out. Okay, so the first thing I need to do is subtract 40 on both sides. I'm going to get 0 on the one side. I can't subtract 40 from x squared or 3x, so I'm just going to write it off to the side. Get x squared plus 3x minus 40 is equal to 0. And now I can go ahead and factor this out. And so I'm looking for the two numbers that multiply to equal negative 40 and that add up to equal positive 3. All right, so you can go ahead and list your multiples of 40 or the factors of 40. How do I get there? I can multiply 40 times 1, 20 times 2. 3 doesn't work. 4 times 10, 5 times 8. And I think that's the one we're going to go with, 5 and 8, right? Because if we have a positive 8 and a negative 5, that would add up to 3 and also multiply to negative 40. So we're going to have x plus 8 and x minus 5. Remember, order doesn't matter here at all. You could have the negative 5 in the first bracket and positive 8 in the second. Doesn't matter. All right, now what are the actual x values? What number plus 8 equals 0? Well, that would be negative 8. And what number minus 5 equals 0? That would be positive 5. So these are your two values of x. Okay? Okay, this is 4.1, triangles and congruent figures. We're starting on the back page here today, looking at equilateral triangle theorem and its converse. I think this is going to be pretty obvious to most students. So if a triangle is equilateral, then it is equiangular, which is a weird word. Okay, so basically what that's saying is that if we have a triangle here, A, B, C, and we know that all the sides are congruent, then we also know that the angles are congruent. So here's that same triangle. We know that all of these angles are congruent. Okay, so then the converse of that, basically saying the same thing in the different order, right? So if a triangle is equiangular, then it is equilateral. Okay, so if got this triangle ABC, and I know that all the angles are congruent, well then I also know that A, B, C, that all the sides are the same as well. Okay. All right, congruent figures. Go ahead and write this down. We've got congruent figures have exactly the same size and shape, and corresponding parts have sides and angles that match. Okay. Go ahead, pause video, write that down. All right, example 1. We've got triangle EFG is congruent to triangle ZXY. Okay, so an easy way to do this, I think, is to just make sure that you understand that the order matters. So E to F to G. Okay, so if E is our starting point and we are going to go to F and then lastly to G, okay, that means the E is going to be our first angle, F is our second angle, and G is our third angle. So when we go over to our congruent triangle over here, we're going to do the same thing. Z is our starting point, and we're going to go to Y. All right, so we're going to go Z to X, then down to Y. And so Z is our first, X is our second, and Y is our third. So what do we know about that? We know that angle E will be congruent to angle Z, all right? Because they have the one arcs, right? And then the two arcs, angle X will be congruent to angle F. And last one, the three arcs, right? Angle G will be congruent with angle Y. Okay? So that's one type of thing where we'll be asked to kind of label what types of things are congruent. And then the second example, we'll just be given these markings and we need to write a congruency statement. Okay, so something like up here. Okay. But again, we can just kind of do the same thing that we did before. We notice that we have this one arc or even the one line, and then we're going to go 1 to 2 to 3. And we can, even if we didn't have the arcs, we could do this with the lines, right? We've got the one line, okay, so we could go one line to two line, and then through the three lines right there. We've got this auto thing on here, so let me delete that. There we go. All right, so hopefully that made sense. Let's go, I'll do it again with the arc. So I've got the one arcs being R to Q to S. So I'm going to say that triangle RQS is congruent to triangle, let's see, one arc, two arc, three arc, or we could also say one line to two to three. It's going to go starting at B over to C and down through D. So triangle RQS is congruent to triangle BCD. Okay. All right, why don't you guys pause the video, give these a shot. All right, let's see how you guys did on here. So we've got triangle RTS is congruent to triangle TRG. All right, so let's see. We're starting at R, going through T to S. So R to T to S. All right, so that would be 1, 2, 3, and T to R to G. Okay, so that would be 1, 2, 3. And what are we looking for here? We've got the segment SR is congruent to, well, SR is over here. SR is over here, and that is in between the single arc and the triple arc. Okay, so that must mean that the congruent segment must be over here at TG. Okay, All right, moving on. So you can certainly go ahead and draw this out, but I don't want to show you guys a trick. You don't really even need to do that, okay? Because we have triangle x or zxy is congruent to triangle zxj. All right, and so we're looking at segment YZ, which would be Y and Z, the last and the first. So we know that we can do the same thing for our congruent triangle and call that segment JZ. Okay? So that little trick might help you save some time. All right, last one here. We've got triangle LMN is congruent to triangle IHN. Okay, so why don't we go ahead and list this out. So LMN, so we're going to start at L and go through N. So LMN, okay, so that means it's going to be 1 to 2 to 3. And IHN, we're going to go 1, 2, 3. Okay, so we're starting here, going through H to get to N. So let's look at what we have here. We have the angle MNL. MNL, that's the same thing as angle. So they can't label this as just angle N because you wouldn't know which one we're talking about, okay? But angle MNL is referring to this one here, okay? So which triangle, or sorry, which angle is congruent to that one? This has the double arcs, so this angle here would be congruent, and we could call that simply angle H because there's no confusion on that one. But if you wanted to label it with 3 points, we certainly can. We could call that NHI as long as H is in the middle, because the vertex has to be in the middle, so you know which one you're looking at. All right. Okay, that's all I got for you guys today. Why don't you guys give the practice problems a shot, and if you still need help, you know where to find me. All right, later.